This week, we speak with Cesar Rodriguez from ACRIX about terraforming planets, or at least cloud environments, to make them hospitable for sentient life, or at least DevSecOps teams. In the news segment, we briefly descend to DLL hell, journey to the end of Flash, enter the state of open source security, check our geolocation on iOS 14, explore a monolith, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Today, cybercriminals are taking advantage of an expanded attack surface to commit malicious activities ranging from hijacking user accounts to making fraudulent purchases. Businesses need solutions that can protect their sites from this increase in fraudulent activity. reCAPTCHA Enterprise is a frictionless fraud detection service that leverages our experience from more than a decade of defending the internet with reCAPTCHA and data for our network of 4 million sites. To learn more about how reCAPTCHA can defend your website or mobile application against fraudulent activity, visit securityweekly.com/reCAPTCHA. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more. Discover a simple way to secure your app without the need for a full security team. With trusted software, simply drag and drop your app and get it back fully protected within a couple of minutes. Trusted software is the smartest zero-touch app protection solution on the market. Change the world one app at a time. With 50 years of security expertise, Erdeto's software security technology and cyber services protect over 5 billion devices and applications for some of the world's best-known brands. To request a demo, visit securityweekly.com/Erdeto.
Welcome to Application Security Weekly. This is episode 112, recorded June 29th, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman. Hello, Matt.
Good morning, Mike. At least you remembered which number we were on, because I have to keep looking it up.
I had to keep looking it up myself. We skipped ahead to 113 for a moment, but then I went and fixed it. So, but off by one error's classic AppSec problem. So I felt at least justified in doing that. We are missing John Kinsella this week. We'll hope he recovers and is back next week with us. But we haven't completely forgotten him, so stick around for the news segment as well. Join the Security Weekly mailing list and receive your invite to our community Discord server by visiting securityweekly.com/subscribe and clicking the button to join the list. It's been good to see some familiar names popping up and saying hi in the Discord as we start each episode, each live stream.
Yeah, there's over 700 total in the Discord server. There's about 150, 160 online right now, and there's probably a good number that'll be interacting with us on the show, so it's kind of fun.
Yeah, and I'll try to keep my keyboard clicking down as I sneak a peek over at the Discord while we're recording this. With all the changes, recent changes to Black Hat and DEF CON, we realize we can keep doing what we do best, which is host virtual podcasts. I'm proud to announce Hacker Summer Camp 2020, a Security Weekly virtual live stream event, August 3rd through 6th, 2020. To reserve your slot now, visit securityweekly.com/summercamp2020. Cesar is the head of developer advocacy at ACRIX and has spent the last 10 plus years working in the cloud security space, securing both private cloud in the military industry and public cloud in the financial sector. He is passionate about contributing to the developer community through open source projects like Terrascan, blogs, and participating in local meetups. Hello, Cesar. Thank you for joining us.
Hey, good morning.
Good morning.
Happy to be here.
And we're happy to have you because we want to talk about infrastructure as code, particularly because it has the word code in it. And obviously our applications, our software is built with code and it has some flaws and some vulnerabilities. So if we take some of that idea and turn it to infrastructure as code, what should we be worried about and what can we do about code that's defining our infrastructure that might be insecure?
Yes, I think let's first talk about how was infrastructure managed a few years ago before we had the concept of infrastructure as code. And I think when I came out of college, one of my first projects was to build a data center. And I remember through that project that we had a bunch of operational procedures and how things would be managed within the data center. We had huge spreadsheets that detailed step by step what action you need to take and what was the outcome that you wanted to take from that action to build this whole data center and put the software on top of it so we can meet our business requirements. So the concept of infrastructure as code is how do you provision and manage your infrastructure using declarative language. So you can use tools like Terraform, CloudFormation, or any number of tools to provision your infrastructure and manage it as code. So it's going to be in a version control repository. You can apply the same concepts that you've been applying to your regular application code to your infrastructure as code, like doing static code analysis for security weaknesses and doing code reviews, merge requests, pull requests. So the same concepts that we've applied to traditional applications, now we can use to manage our infrastructure through code.
Cesar,
oh, go ahead.
I was going to say, Mike, I mean, his days of building data center are different than mine. I mean, I used to crawl under the floor, pulling fiber cables and, terminating the ends and plugging them into a DECnet switch. And infrastructure and data center builds have changed a lot over the past 20 years for me.
Yeah, definitely. I think, so I did have to do a little bit of that for pulling cable, but definitely will be different than 20 years ago. My data center project was around 12 years ago. So
yeah, now you don't even have to do a lot of that. I mean, I think exactly. Mike, this is where we're going, right? Is we don't even worry about the hardware necessarily in our data centers anymore. We look at the cloud providers who have built out aspects of this infrastructure and we say, spin me up an EC2 instance with this configuration, go.
Yeah,
and that's what's got to be different. You're running. Yeah, go ahead.
No, it's like magic. The things that you had to do before and what you can do now, where you can have your whole data center defined as code, and it can be provisioned in a couple of clicks in a few minutes, and you have a whole virtual private network with instances, load balancers, and everything ready to go.
Yeah, and it's got to be it's a different group of people also potentially even designing this data center, because now it's the developers that are running, ostensibly these virtual cables and labeling. So they're spinning up the instances, and it doesn't matter too much which rack it's going into. They just care about regions. So, and I think that's why we've seen this concept of DevOps or DevSecOps, that building that data center is who's doing the building is changing. And I think that's interesting because developers, not to say that they don't understand or appreciate the infrastructure, but in a lot of ways, maybe they don't just care necessarily about the nuances of the scaling. They just want to say, here's my app, it's running. So I'm curious, as they do that, or as you've seen these declarative languages build up infrastructure, are there particular patterns or mistakes that you see that, because it's a different type of complexity now for developers to consider?
Yeah, definitely. I wouldn't say there's a particular pattern or mistake. It could be everything, but definitely as developers are learning how now their application interacts with the environment, and how do you make an application that can scale better, be auto-scaled, be stateless. There's a learning curve to that, and there's definitely mistakes that could be made that hopefully we can remediate doing some techniques like static code analysis.
Yeah, I mean, auto scaling is, I think, an interesting challenge in that when you think about when you put an app out there and you kind of do the initial configuration and you have your infrastructure running, scale up gets interesting because what's the default configuration that the autoscaler code is pulling? Is it pulling your secure configuration that you spent all this time to build, or is it pulling some default configuration, because we've seen this in some of the different cloud services, is that sometimes the auto scale pulls the default config, not the secure config, which could create a huge set of security holes in your infrastructure.
Yeah, definitely, it's something to be aware of. So, and one of the things that we see that we've seen is that most companies. So we like when we do infrastructure as code, we also like to introduce the concept of immutable infrastructure, where you're defining your infrastructure as code, and that same code is the golden source of how your environment would be. So in practice, what we've observed is that most companies have some sort of break the glass process, where if there's an issue, an incident, people will go and manually modify the cloud environment, and that's where it can cause issues where you accidentally rolled back and you went to your insecure configuration for your auto scaling group. So it's something that we're trying to mitigate, and we're trying to address. How do you address the drift from your cloud environment to your infrastructure as code? Because you want to make sure that any changes are always reflected in your code.
Yeah, and that drift has to be one of the biggest dangers, because and I agree with Matt. The idea just make it immutable, and anytime a human touches your production environment, burn down that resource and redeploy it from that immutable baseline or that secure baseline. But when this drift happens because of break glass, or someone's responding to a SEV or trying to fix something quickly in production, how do you see people trying to identify even when that happens? Because even just knowing that drift happens is bad, but detecting in the first place has got to be tough, because there are so many different components that can be defined within your infrastructure.
Yep. So if you're trying to detect manually without a tool like what we're trying to build, it's very hard. You need to look at your logs to make sure that you detect when somebody's making changes manually, making sure that you can differentiate from good changes to bad changes. So any changes that changes your security posture or the operational postures and your guardrails that you're trying to put in place, those should be detected and alerted. But it's definitely a hard problem to solve if you're trying to do it manually. And it's something that we're trying to address with our product.
Well,
So
and that's what's, go ahead. Mm-hmm.
I love these little delays for us, Mike. We kind of like step on each other. But in order to do that, though, you have to look at both sides, I assume, right? One, you have to look at the infrastructure as code, the configuration of how that's set up, and then you have to monitor those configurations in real time and compare what is supposed to be in place versus what's actually in place. It's having both the static and the runtime side in order to really understand where drift happens. Is that correct?
Yeah, definitely. You have to be looking at what are the changes that are put, what is your current state of your code looks like, and is this what's currently reflected in my runtime environment. So, and at the same time, you need to look at what is the security posture of my infrastructure as code, and how does that compare into my runtime environment? So if somebody made a change to your infrastructure as code, you want to make sure that you detect any security weaknesses and remediate those, and at the same time, or alert on those. And at the same time, looking at your runtime environment, if somebody makes some changes, how does that affect your security posture, and how can those changes be put back in place into your infrastructure as code so that it can be the golden source of truth?
I'm curious, making those changes, though, has to be a little bit dangerous, because, you mentioned the break glass. So that's sort of, there's an emergency, there's something that needs to be addressed quickly in production where a human needs to go and make a change. And I imagine that, developers or DevOps teams are going to, push back, possibly rightly so, about automatic changes being made in production systems, because they don't want something that unblocked a service or fixed a problem in production to be then automatically rolled back in some sort of self-healing mechanism that actually goes back and reintroduces the same problem that they had manually fixed. So how do you then approach that remediation aspect without making the ops team's life harder and changing infrastructure out from underneath them, while still, as you said, trying to identify that drift and truing it up back to what was the desired state for that system?
Yeah, so a typical approach to mitigate security issues in the cloud environment is to do something called event-driven security, where you use something like AWS config or cloud custodian automatically remediate issues in your cloud environment. But like you mentioned, that approach has some challenges because now your cloud environment has drifted from your infrastructure as code. You usually don't, when you're doing apply changes directly to your cloud environment, you don't have the context of what the development team was doing that to make those changes. You don't know if you're going to affect a business process by doing those changes, or what's the potential impact. When you do those changes, so definitely there's going to be pushback from development teams if this is not well known. So one of the things that we try to promote is something called remediation as code. And remediation as code is when it's okay to look at what are the changes in your cloud environment. And once you look at your changes, if they drifted from your infrastructure as code, you want to know if it's a good change, like if it improves your security and operational posture, or if it's a change that puts you at risk. If it's a change that put you at risk, you want to make sure that that's remediated. So with remediation as code, our goal is to automatically open a pull request or a merge request to the version control system where your code is located. So now your development team can review and can learn about, hey, this is a security issue. We think this is a risk because of these reasons, and this is the code you need to fix it immediately. So that's the concept of remediation as code, and that's what we're trying to promote, where you're not changing the environment underneath from what the development team is trying to do, but you're putting any changes that need to be fixed directly into the code.
And that's what's really cool, and why I like the idea of this as code approach is that what you just described, you can apply really good static analysis to it to find the problems, as well as generate those merge requests so they can be automatically fixed. It's sort of like the Dependabot version from GitHub, for example, that rather than fixing dependencies, we're now actually fixing the entire infrastructure. And I think one of the other things, and maybe you have some other examples here too, is that we haven't even talked about drift from an attacker's perspective, them making changes in production. We're talking about mistakes that can happen or misconfigurations in complex environments where changes to a VPC or changes to a security control could expose something, unexpectedly expose a resource to the internet. Are there other, if we were trying to rattle maybe not a full top 10, but a few other types of issues that come up, what would we be looking at from a static analysis perspective of infrastructure as code?
Yeah, so there's multiple issues. One is not encrypting sensitive data, exposing the environment to the public internet inadvertently, exposing the environment to other cloud accounts. So you can accidentally expose your environment to logged in users, but not necessarily from your account. Not having proper logging, if that's a requirement, or proper not monitoring, if that's a requirement for your organization. And the most common one is things like exposing SaaS service from the cloud providers to the public internet, things like S3 buckets, queues. That's the most famous case where people accidentally have their files and records out there in the internet without authentication.
So it really sounds like you're turning that old, that first approach you described, building a data center with, thick run books of do this, then do this, and if this happens, do this other thing, and spreadsheets. It sounds like you're even describing, there's a policy as code that's emerging here too, if you can detect all these problems. So that sounds like a really compelling issue or reason, yeah.
Yeah, so with policy as code, it's you convert all of your requirements into code that can be applied to both your cloud environment and your infrastructure as code. So if you have a requirement to have encryption on your S3 bucket, for example. With policy as code, you can automatically detect when somebody is creating a S3 bucket that doesn't have an encryption turned on and raise an alert. And if they're doing it in the cloud environment, you can follow the remediation as code approach and open a merge request, a pull request, so that they can fix that if that's one of your requirements.
And you're not just creating policy as code from a security perspective. There's a resiliency play here as well, which is if you're making a bunch of changes in production and they're not getting reflected back into your infrastructure as code repository, and an issue happens, you can't restore. Your immutability is gone to restore those systems to what was running in production because you're not managing that drift change back from runtime to static, right? And so part of this solution, I think, also addresses some of the immutability resiliency requirements of people running in these cloud environments as well.
Yeah, definitely. And I think that's a big concern, and it's how, and it affects security. Like if you're not taking care of your environment, if you're doing manual changes and the resiliency of your environment is going to change, it's also going to affect your availability if there's an issue or an incident where you have to restore back to the known good state.
Yeah, exactly right. Yeah.
How have you seen this change or this approach change or affect the conversation with security and the DevOps teams? And I'm thinking in terms of, the developers, identifying this infrastructure and then, security coming. I guess maybe I'll ask it this way. When does security come in and say, this is a good environment, bad environment, or here are some policies to enforce, things like that? How have you seen this worked out in practice in organizations?
So in practice, I think the biggest unlock is that when you have your security requirements defined as code, you can publish them out there for every development team to look and to improve upon. So I've had many cases where we have our infrastructure as code, our policy as code stored in a repository, and there's development teams that notice, hey, this might not be as good as it's supposed to be. Let me as a developer issue a pull request so we can fix the security posture, and that increases the resiliency and the security of our whole environment, not just what the development team is trying to do. So from a security perspective, it's better because you have more eyes and looking into what your security policies are. And then from a development perspective, now they know what are the security policies that apply to their application, to their systems. So they're more involved in the process. So it breaks down some of the silos that we had before, where security was handled more like a black box and development teams didn't know how were the security appliances configured in the environment. So I think it increases the partnership between development, DevOps teams, and security.
Cesar, how far back can Accurix pull that visibility into the development pipeline? What I mean by that is, obviously you can probably catch it at build, right? Because you can look at the code statically there. Can you pull some of that policy even back into the IDEs as people are developing this code? How far back can you actually get that visibility?
Yeah, so right now we are integrating ourselves as part of the pipeline. And we currently don't support the ID integration yet, but it's something that we have thought about. But definitely we can integrate into your CI/CD pipeline and integrate into your cloud environment. We want to make sure that we shift security as much as possible to the left, making sure that we integrate with the developer's workflow.
Right. So, and then all that remediation as code comes back as what? A JIRA ticket? How do the findings from that remediation come back and get into the developer's hands?
Yep. So if it's there's two types of issues. So if we detect that when you made a change to the environment, you did a change that improved your security posture, we want to issue a pull request to your system so that you can integrate that into your source of truth, which is your infrastructure as code. If we detect that the change that you did in the environment drifted away and put you at risk. We want to make sure that you return back to the source of truth, which is the most secure version of your code. So we want to open a Jira issue automatically, so somebody from your team can look at that.
Got it.
Yeah, and those are that's absolutely great stories for building up for improved tooling and visibility for the development team, for the DevOps team. I'm also curious too, bringing security into this as well. You have Terraform, you have this concept of what the environment ostensibly looks like, so that you can also identify when drift happens. If you have all this information about the environment, can you then also roll out some, from the security team's perspective, some what-if scenarios, in the sense of, what if this particular service is compromised, or what if someone gets access to this particular IAM account, or this particular encryption key? What could happen? So could you sort of show the blast radius, if you will, of what happens when things go bad?
Yep. So definitely that's one of our capabilities, and we call it breach path protection. So prediction. So if you think about the way traditional security or application security team is done, it's mostly point in time and interview based approach, where a security person meets with the development team to figure out what the development team is trying to accomplish in terms of their architecture, and based on that, you give them security requirements that now they need to go out and implement. So that approach obviously doesn't work, because you're just interviewing them at a point in time, and you don't know how their application is changing from week to week, especially in a cloud environment where development teams are experimenting a lot, learning and iterating quickly into applying the changes that they need to their architecture and to their applications. So with our threat modeling approach for breach path prediction, we collect the data that we have for your architecture, and we can tell you what are the particular risks to your architecture, and what are the particular path in your environment that could potentially be breached with the information that we have.
So instead of doing like a full-blown live breach and attack simulation, what it sounds like you're doing is you're taking the configuration files and actually doing some of that prediction without it actually running. You're looking at the static code saying, based on what we know about these different configurations, here's where potential weaknesses in the infrastructure would exist before I deploy. Is that right?
Yeah, definitely. And not only that, we visualize it. So now you can see what is the infrastructure that's out there, what's your architecture, what does it look like visually, and then we show you what is the potential breach path on that visualization, so you can know, so you can better assess what are the risks that you have in your environment, and what are the things you need to fix first.
That's pretty cool.
That is, and because I love the idea, because that's very much like when you have this information about what's actually running, or at least very close to what's running, because drift may happen, you have that, the map actually pretty closely matches the terrain, which is much more informative when you're trying to build these ideas of whether you're trying to apply a kill chain analysis to figure out where some additional controls could be or should be deployed, or just as you've been describing, some breach scenarios. That's a really cool capability that emerges from being able to just inspect your infrastructure as code and do analysis on it.
Yeah,
plus,
definitely. Go ahead.
I was gonna say, plus, just think about this. How many organizations really know what these new applications look like in production? I mean, think about what organizations are building with all these microservices, all these different cloud services. I mean, what does the app actually look like? I mean, just visualizing aspects of that and being able to show people, like, here's your app, that's a huge benefit on its own, let alone when you then apply, attack simulation and some other predictions on top of those configurations.
Yeah, absolutely. I think we could probably launch a whole new podcast series that's just basic asset inventory security weekly, because so many things evolve from that. Well, I know, Cesar, this is, speaking of point in time interviews, this is just a point in time interview with you, and things, your own application may be changing. You mentioned bringing some of the analysis into the IDEs for developers. Anything else that you wanted to highlight for some upcoming features or changes or things that we could be looking forward to from this approach?
Yeah, so first of all, we want to bring more of our capabilities back to our open source. So with TerraScan now being part of our Arcturix, you'll see more capabilities. We'll put more of our static code scanning capabilities into the open source for everyone to use and to contribute and to learn more about how we're doing things. And on top of that, we're bringing more capabilities into systems and clouds that we can scan. So things like service mesh, Kubernetes, cloud providers will be working heavily into increase our scanning capabilities and the overall package of our product.
No, very cool. And I think, yeah, that's actually one of the things we didn't even touch on really, is that with investing and looking at something like Terraform, that could still apply to a degree to data centers, but even hybrid environments and multi-cloud environments. So it's not like there's a particular, there's a great flexibility here, it sounds like, as well, from this type of approach.
Yeah, I think what's most important is, as you build your capabilities in the cloud environment, if you still hybrid, think about what are the possible workflows and approaches that you can retrofit back into your on-prem environment, be it infrastructure as code, policy as code, remediation as code, the way that you handle secrets. Those are all things that could be put in place through your whole organization, and then you have everyone in the same workflow, which will increase the velocity that you're deploying of your deployments and also increase your security and resiliency.
Yeah, and I think with everything as code, we haven't quite gotten to Cesar as code, so we do appreciate that you came here to talk to us in person. Thanks.
No problem. Happy to be here.
Happy to have you. Also happy to have Matt here as well, of course, and also thank you everyone who joined us. We're going to take a quick break and return with news of the week.